surface, out of sight.
Welcome everybody to the 7th episode of our BlueShift podcast. The title of this one is about the ocean in motion, how hidden currents shape Earth's climate. And today is a great pleasure for me having over here the Associate Professor Borja Aguiar. Thank you so much for being here, Borja.
Thank you for having me.
He is an oceanographer and he's working at the same university as me, the ULPGC, and he works in teaching applied physics, and he's also interested in distinct oceanographic regimes. We are talking about upwelling, eddy corridors, and this kind of stuff. And now you are involved in biophysical models, how to integrate ecology and biology with oceanography. Exactly. So today, as a brief introduction, is the ocean is constantly in motion. We got currents, eddies, tides, and internal waves that are, giving nutrients, salt, heat, carbon around the planet. They contribute to that, and they are so having got a pivotal role to the climate change, how they affect the climate change. And we are going to be developed further during this, this informal podcast, and also to see how this, your work is really important about how these movements occur at intermediate scale. So we are talking about eddies and boundary currents in the middle of the Atlantic Ocean, for example, how they affect the whole planet. Yeah. So just trying to, break the ice, just as a first question, how do we actually mean when we talk about ocean circulations? Why should people care about it?
Yeah, so this is a key part to understand the role of the ocean in our climate system, and is that the ocean is like a player in a board game, and that player, the ocean circulation, we have to think about it as moving belts around the planet, and these moving belts are currents that are transporting heat, salt, nutrients, and other ocean properties. And the role that they play is that they are redistributing these properties around the globe, so they are in balance. And that helps to keep the climate as we are enjoying it right now. So the study of, as a physical oceanographer, we have to study the motion of the ocean and monitor how it evolves in time to see if there are anomalies or something different is happening, so we can predict in advance what may happen in the future if this is changing in the actual scenario.
Okay, sounds really interesting. So now we know about the role of the ocean into the climate change, but most of the people see in the news that there are certain areas, like for example the Antarctic or the Arctic regions, they are so sensitive to climate change, that they are changing so quickly. Why is that? Why is that the climate change affect harmoniously the whole planet? Why certain spots like these polar regions are more affected than, for example, I don't know, maybe the mid-Atlantic?
Yeah, so the ocean is not just water, it's the element that makes the planet a place where we can live and makes life possible and suitable here. So in these regions, as you said, the Antarctic and the Arctic, we have stores of fresh water. There is a lot of fresh water being stored in the way of glaciers, ice sheets, snow, marine sea ice. So if there is a rise in the temperature, if we are experiencing global warming, that fresh water will be released to the ocean, and that will create an imbalance. And that imbalance will affect ultimately the climate. Why? Because the ocean is the player in charge of redistributing heat and salt around the globe. So if you introduce such an anomaly as a large amount of fresh water in the poles, then you are introducing an element that is not currently there, and it will be a cascade effect with feedback mechanism and etc. that we are still trying to understand, but that ultimately will change the climate that we are enjoying right now.
Right now, and also you can see in intermediate scale. For example, we can see the western part of the Atlantic Ocean compared with the eastern part. Yeah. People that are only living here, for example, in the Canary Islands, maybe they don't have the opportunity to experience this kind of, hurricanes or maybe heavier storms or heavier snowfalls that you go, for example, on the eastern coast of the U.S. Or maybe even the Caribbean Sea, where you can see there are maybe most of the time 3 or 4 hurricanes each year. Does the ocean has a role in that as well?
Yeah, and that's an important point for the people to understand that when we are talking about climate change, it's not something that is going to happen in the same way everywhere. So as you say, in the Canary Basin, we are not experiencing those hurricanes or strong snowfalls. But it's true that the extreme weather events are occurring at a higher frequency, for instance. And the thing is that we have to think about the ocean climate system not as a linear system. So if something happens here, we will have this consequence. No, it's not like that. So there are multilinear responses, feedback mechanisms. So if climate change is already happening, but not in the same way in every part of the world. That doesn't mean that it's not happening, and eventually it will reach us. So it's not something that because it's not happening to us in our region or we are not experiencing it in a strong way, it's not happening. So it's happening globally, and because we are all connected, that's the term that we use in physical oceanography, teleconnections. We are connected.
Yeah.
We have seen that when there is an eruption of a volcano, that signal is circumnavigating all around the globe. We are all connected with the same fluid, the atmosphere. So the same happens in the ocean. So if something happens in the ocean, eventually it will reach us everywhere else.
Okay, that's for sure. So we have seen that this is one of the huge effects on climate change in the ocean is about warming.
Yeah.
There is another one, maybe it could be anoxia, we can see acidification,
Yes.
we can see even eutrophication because of human activities. But warming, I think, is like the top of ones that, affections are warm. So this kind of warming affects only the superficial waters of the ocean or the ocean column, or maybe you have seen, because I read a paper a couple of years ago with one researcher from the Oceanographic Institute of Tenerife, talking about maybe the intermediate layers. We are talking about 200 meters down, 500 meters down, are also being heated by the global change. That is correct?
Yeah, that's a really good question, because actually usually we think about the global warming in the surface layers, but it's not like that. Yeah. And the problem is that it's reaching deeper layers. And when that is happening, it's a clear signal that the anomaly is becoming enormously significant. Because if you have, you can have a heat wave during a couple of days in the ocean, but as soon as the wind starts blowing again, it will refresh, mix, and then the temperature recover its regular values. But when that happens in the deeper layers, you don't have the wind for producing that mixing and that refreshing. And the fact that the deeper layers are increasing the temperature, it means that global warming is not something happening only at surface layer, but it has going across the ocean and reaching deeper layers. And that, of course, will affect to the biota living there. It's not only about us. We have to think also about all the living creatures that are in the ocean and will be affected. But that global warming that is happening in the atmosphere, but also in the ocean, not at the surface level, but at deeper levels as well. And that is recorded and is already confirmed that heat has reached deeper levels.
Okay. There is a basic question that I got from my students most of the time. This is about, the correlation between, like cold waters and eutrophic waters, and also oligotrophic areas, like, for example, here, the Canary archipelago, and maybe warmer or subtropical or tropical. Could you develop a little bit further in the oceanographic aspects? How this correlation could, why is that?
Yeah, so usually as a grad students, I get, from the grad students, I get this question a lot as well. And we associate the cold waters with the nutrient-rich waters because they are coming from deeper levels. So remineralization, which is a process that creates these nutrients at deeper levels, through physical mechanisms in some parts of the ocean, they can rise and reach the surface levels. And at that point, there is a combination of light at the surface level and nutrients. So then there is a bloom. There is productivity, and then the biota can grow. What happens when we have warm stratified waters? Those stratified waters, when we talk about the stratified waters, we are meaning that we have like layers of different density waters, like if we have water on top, oil, and etc., depending on the density that they have. So that stratification implies a barrier for the nutrients to reach the surface. If we have a barrier that avoid the nutrients to reach the surface, we cannot get the combination of light and nutrients. And that's why we associate the more warm stratified waters with being more oligotrophic. Oligotrophic meaning that it's less productive and there is not this high production. And then the cold waters where we have more mixing and then the nutrients from the deep ocean can reach the surface and combines with the sun.
Okay, that makes sense. Yeah, that's for sure. And when we are talking about, I think most of the people, they don't have a really good separation between weather and climate.
Yeah.
And for me, it's time. It's just like having like a long-term series or long-term, data series. I think is crucial. It's really extremely important about that. So, but what can historical data about the ocean, tell us what is happening today?
Yeah. So I love this question. Before addressing it, I would like to explain in a simple way what's the difference between weather and climate.
Okay.
So when you wake up, open the window and look at the sky, what you see is the weather.
Yeah.
Is it sunny? Is it rainy? It's cold? It's warm? That's the weather of today on a daily basis. If you do that, and during 30 years, 3 decades, you wake up, look at the sky, and write down what you see at the sky, and you identify a pattern, that long-term pattern of the weather is what we call climate. Okay. So that's the difference. The weather is on a daily basis. The climate is the long-term variability of the weather. And then, addressing your question, having historical data is key, because knowing what has happened in the past, we can learn and understand better what we are experiencing in the present, and also get the skills to predict better what may happen in the future. And it's the same as history for civilizations. If we know what happened in the past, we understand better what we are experiencing now, and we could stop things that could happen in the future.
And what is the bunch of data, of oceanography data worldwide? Is a scattered data that you got really good data from, I don't know, Bahamas or certain places, and maybe offshore Hawaii, just to say one place, or maybe there is a really good, like, consistent data, because, for example, in our field in ecology, we got a couple of hot spots in terms of data, that having good sampling continuously each week, even each month, for 40, 50 years. For example, in the coast of Plymouth and south, western of United Kingdom, of UK. But here, for example, in the Canaries, we got only, even I talking about really basic stuff, about the intertidal or maybe tide pools close to the shore that are really, you could take data so easily, but we don't have this kind of data. Have you got the same problem when you're talking about oceanographic data or not?
Yeah, so in terms of oceanography, we have the same issue of hot spots and areas with data gaps. For us, it has a lot of value. Long time series that there is one to the north of the Canary Islands, the Stock Station, doing a really good job in maintaining long-term monitoring. The same in Bermudas and the same in Hawaii. So there are certain points in the globe where they have been monitoring for decades the ocean properties and how they are evolving in time. But close to the coast, we have the network of buoys from Puertos del Estado. Also, the IMET has meteorological stations all over the country, and those data are open access, so you can just apply for them and download them and study them. So that's, let's say, inland or close to land, those are the stations that have long-term data. When we go to the open ocean, it's shocking, because if you look at the map, you see the rich and the poor countries' contribution to the science in the ocean. So the North Atlantic is full of data, plenty of data in real time, producing data in real time. But then if we look, for instance, to the Indian Ocean, there are huge gaps of data. Yeah. So just comparing by ocean basins is a matter of what country is next to that ocean, and if it's a rich country that invests in research and science, there will be many more data, continuous data in real time being taken. And if you go to other ocean basins, you will find large data gaps. And the same happens, so the most undersampled oceans are the Indian Ocean, and then because of the hard weather conditions, the northern and the southern hemisphere. So the Arctic Ocean and the southern oceans, because it's very difficult to take measurements there because of the conditions.
That's amazing, because it's happened the same here. I think money it has a key role on funding for sure, and maybe this is you have seen at the same time on the field. So that's amazing. So one of the things that you are, when you are a non-oceanographer like me, the kind of researchers that are out of oceanography, they, for example, in my case, I get amazed about, you having also many connections inside oceanography. You have physical oceanographers, you got chemical oceanographers, you got biological oceanographers. And now you told me that you are working with biophysical models.
Yeah.
What does it mean? Could you just explain a little bit about the different, areas or topics that you are drawn into at the moment in your research lines?
Yeah, so that's a thing that I realized for the first time when I did part of my PhD in the Netherlands. And I learned that the degree in marine science is not something that common in other countries. So in South America, yes, it is, but not that much in the US or in Europe. And the good thing of the degree of marine science and that perspective that I have in my background knowledge is that we learn to study the ocean from different point of views. Mathematics, biology, geology, physics, chemistry. And actually, when I have to introduce myself, I try always to remember not to say physical oceanographer, but to say oceanographer.
Oh, okay.
Because when I have to study the ocean, it's true that my background is more well-founded in physics, but I also have to address problems in chemistry, biology, and etc. Of course, if something very specific, I will have to go to a chemist or a biologist, and I don't try to say that I can control all these disciplines, but my focus is on physics. But I know that it's important that I talk to biologists, I talk to chemists, and I talk to geologists and etc. to understand the problem as a whole. And that's the reason why in the last years I have more and more interested in biophysical processes. And it's what I call where physics meets biology. So how the physics of the oceans are shaping the biology, the community structure of the biota that we observe, and also the cycles that they experience through a year.
Okay, so amazing. It's amazing because I think you're like touching certain topics and maybe you're speaking the same language of one way or another. And this is so amazing that maybe, for example, you could interact with a wide range of researchers with different backgrounds. So I think it could be you enrich yourself, even your research line, even in personal aspects as well. It's amazing. How do you think, the oceanography will change in the coming years? You haven't got a really good, as far as I can see from my, my readings, a really good level of data and, models and about, field surveys, everything like oceanography campaigns. But what is going to happen with oceanography in the coming years? There is going to something change. What about technology? What about gliders? What about another kind of models? Do you think there are going to be certain areas are going to be expanded further than compared with the current situation?
Yes, absolutely. So when I started the bachelor in marine sciences, it was in the 2000s, and I have had the opportunity to see an explosion of knowledge that is open to anyone that wants to study the ocean. So when I studied the Marine Copernicus service, which is marvelous to go there and just see the bunch, the amount of data that you can download by yourself as a student. So that gives everyone with curiosity and interest the opportunity, combined with knowledge, to explore and to contribute to oceanography. And satellites, of course, are a key point. Why? Because what we were discussing just a few minutes ago, we have large areas with gaps in data. The satellite doesn't care about what country is rich or poor. They are looking at the whole planet. So now we have data that in previous decades we couldn't even imagine that we would get that whole view of the planet. So for sure, satellite has made one of the most important contributions to oceanography, but also marine robots, as you said, gliders. Mm-hmm. So robots that we can control from the computer in our desk. We just release them in the ocean, and then we monitor them from the computer. And then drifters, floats that are drifting away alone and taking measurements systematically. All that is contributing, and even now we have fleets of animals that we tag with a device. Like we have our smartphone with the GPS, so we tag the animals with devices that are not harmful at all for them, and they are registering passively temperature and depth, and they are contributing and enhancing that network of data that we will be able to have access, that in the last decades that didn't exist.
Okay.
So we are in a great moment for oceanography.
Okay, that sounds so amazing. So I know that you have so many students in your team. You got like several, maybe I don't know, several PhD students. When you are really deeply involved in academia as well, that you would like to launch maybe like another courses, postgraduate courses, and this kind of stuff. That is hats off, because it takes so much time. When you involve these kind of early career researchers, how do you do that? Maybe, for example, we consider in our team that this is a horizontal team. Everybody has its own, area of expertise and maybe contributes to the hub of the team. Is the same, of course, to you? Could you give me some kind of examples maybe of the PhD students, their topics? Why are they interesting to you?
Yeah. So for me, when I do the interviews for a new team member that wants to join, I actually never ask for the grades. And that's something that some people tell me why I do it. And it's because the grades don't tell me anything about if you are going to be a good researcher or not, or if you are a good team player or a lone player, let's say. And I'm always looking for people who are curious, that have interest and enjoy what they are doing, that they are just not following the inertia, because sometimes we just do what is next, what we have been told that is next. Now you do a PhD. No, you don't have to do a PhD if this is not the thing for you. So I always talk to them to make sure that they are doing it because they want that, and they always explain them the same as you said. This is a horizontal group of people where we are having regular conversations and discussing and exchanging knowledge. But I also encourage them to collaborate together and never see the person who is sitting next to you as a competitor.
No,
because that's horrible.
Yeah.
It's horrible to work in that environment. Yeah. So then I really encourage to see the benefit of helping each other. Because if you help your colleague in the future may know some methodology that you need for your research and will feel grateful and will give you back that knowledge that you provided at some point. And also makes you feel relaxed in your work environment. And then you eventually end up enjoying the job, which is what we are here
most of the time.
We are here to do.
Yeah, you are right. And also, for example, I got one of my supervisors when I was in a postdoc in Australia told me that the first thing that you have to do, you have to work with people that you feel comfortable with.
Yes.
The other thing is like a tick box, at the beginning, know. And maybe you put your net of collaborators, international collaborators, to the service to your students. You put it out like, this is my collaborators, you could use them, or maybe you could contact them, start collaborating.
Absolutely. At the moment, there are 2 students in South Africa, in Cape Town, and they are doing an internship of 6 months. And I just put them in contact with my collaborators there. I feel them as mentors to me, the collaborators that I have in South Africa. So I co-supervise thesis of students of them remotely, and I do the same, like vice versa. So It's open doors, not closed windows
Okay,
or whatever. And if I always tell them, well, if you want to do a PhD or an internship in some other place, and I can help you out, let me know where you want to go. And what I always say is, you have to respect the research group you are going to. So study first the history of that group. Who are those people?
Yeah.
What are the papers, the research that they have been done? Study the group, because then you are showing respect when you arrive to the interview and you know the people that you have in front of you.
Yeah, I think background is really important. Just trying to be aware about the background of your host institution, I think is amazing. That would be great. And also, what is your aim when you got this position as a professor here at Oceanography? And you know there is the Oceanography department, like physics department or maybe chemistry department. There are so many professors. So you would like to launch a new research line to create another net of collaborators, constitute a hub of science here on Oceanography. What is your main goal here?
So
sorry about the deep question.
I know, and I'm getting emotional actually. So. It's true that I opened a new research line when I arrived here, and it's the research line of combining physical oceanography and animal telemetry. I briefly told you before about that. So it's using animals collaboratively with ecologists, vets, and biologists. So I get temperature data from remote places that I couldn't get data from in any other way. And the ecologists and the biologists get information about the behavior of those animals. So there is a feedback between these two disciplines. So that's a research line that I trust a lot on it on the future, and I put a lot of effort. But the main aim of my career is what I finish it, I look back, and I see the people that work with me.
Great. Yeah.
My legacy is not my papers.
Yeah.
I want my legacy to be the people that I work with.
Yeah, and you could feel proud about it and everything. So that's fine. And what is the key message, just as a wrapping up message, okay? The key message that we want to send to the people, to the general public, to take away about the importance of the ocean.
Yeah, if I would have to say it in one sentence, I would say that the ocean is not just water, it's the element that makes the planet suitable for life as we know it. So we must protect it if we want to protect our own lives. That's the message.
That's great, because most of the people see an ocean like a massive, amount of water, and there is something else at all. Yeah. So thank you so much, Borja, for having you here. It was a great pleasure just trying to have this kind of chit-chat with you, just trying to improve our knowledge and trying to create like another vibe here in the UAPLC about science and how science is affordable for all the people and all the students. So here is the end of the 7th episode of The Blue Shift, and as always, stay clear, stay calm, and stay blue. See you in the next episode.
Beneath the surface, out of sight, currents carry heat and light, stories written